This is Mr. Sindel bringing you a video for Integrated Maths 1's Module 6 test. Let's dive right in. Number 1, which graph shows the solution set? Just be careful with this one. Usually whenever you try to graph, you want the variable on the left-hand side, which means you need to switch this to y and -4. Whenever you switch the sides, you need to switch the sign from a greater than to a less than. This less than is pointing the arrow to the left, which means we're going to the left. So these two are going to the left, and the difference between these two, this one is a closed point, this was an open point. Open point because there's no equal to sign. The correct answer here is A. For number 2, fill in the blanks. We want to say we are going to the left of 5, so we're going to the left of 5, so the correct answer here is 5. And going to the left, these both have an arrow that says we're going to the left. It's a closed point, so we want the equal to sign, so it's a less than or equal to. For number 3, Jen's assignment is to read at least 85 pages of the novel. So she's already read 31. So she's already read 31 pages, and it needs to be, this thing needs to be at least 85, at least 85. So the solution, you can just subtract 31 on both sides. So if I do that, I could say minus 31, and now P is isolated because these are canceled out, and 85 minus 31 is 54. For number 4, which is the solution set for this thing? We need to do some math, and I try to move my variables first. So I have my 7y. I'm going to move it to this side by subtracting 7y, That means I have 1, which is greater than a 1y. You don't really write the 1, you just say y, so just y. Minus 9. Let's move the 9 to the other side over here. We're going to add 9 both sides, plus 9, so therefore 10 is greater than y. And notice that in all of these, the y is on the left-hand side, so let me swap the spots. It's going to be y and 10. If we swap the places, this sign also swaps, so we switch this to a less than. We want to say y is less than 10. Y is less than 10 is B. We're on to number 5. All right, so in this case, I'm going to rewrite this problem so I have some more room to talk about. So I have negative 3 over 8x is less than or equal to 24. To isolate our variable x, we need to get rid of this negative 3/8. It is being multiplied by the x, so we don't add 3/8 to both sides. That would be incorrect. We need to undo multiply by 3 and undo divide by 8, and we can do that all at the same time. Watch me work. Okay, so I'm going to multiply by 8, divide by 3, divide by 3, and I'm also going to multiply by a negative. If I multiply both sides by a negative 8/3, watch what happens. A negative times a negative is a positive, so that goes away. This 8 and this 8 cross cancel. That's how fractions work. And this 3 and this 3 cross cancel, leaving behind just the x. The x is left over, and what do I do over here? You could multiply 24 by negative 8, but it's much, and by the way, you can multiply 1 by 3 for the denominator, but what's much easier is to first do this problem. What is 24 divided by 3? Well, the 3 is going to be used up and turned into essentially a 1, and 24 divided by 3 is an 8. Now in the numerator, I have 8 times negative 8, which is a negative 64. And be careful here. I'm technically incorrect when I write this because I multiplied by a negative right here. Multiplying by a negative switches the sign from a less than or equal to a, let's go ahead and erase this, to a greater than or equal to. So there's my final answer. It's greater than or equal to negative 64. X is greater than or equal to negative 64. We can write that in, greater than or equal to negative 64. For number 6, solve this inequality. Well, that one's pretty straightforward. Divide by 5, and therefore x is less than 12. And then it says, then describe how the graph will look on a number line. I can describe how the graph would look, and I can actually do it itself. So the graph is going to look like this. There's my number line. There's 12. It's going to be an open point, and it's going to go to the left of 12. And I'm just going to be lazy, and I'm going to type that in. Done and done. All right, number 7. Select all possible solutions to this thing. Okay, well, let's go ahead and solve it. The first thing that I try to do is make sure I have variables on the same side. I see the variables are bigger on my left side, so I'm going to move it over this way. I'm going to go ahead and say minus 18y. I now have 2y is greater than negative 5. And then from here, I'm going to divide both sides by 2, and y is greater than negative 5/2. Another way of writing that is decimal, just in case I don't like the fractions, is I could say y is greater than negative 2.5. Those are probably the two different ways. And it says all possible solutions, so I can select all of these if I need to. It's not just one answer. So the first thing that jumps out at me is the answer that I had right here. So it's definitely going to be B. The next thing that jumps out is how I convert it into a decimal right there, and that's going to be option A. I'm looking at this one. Okay, inequality going the wrong way. The y is on the other side. Okay, hold on. Let me rechange this. So if y is on the left and negative 2.5 is on the right, then I would switch this sign to be a less than. Okay, this sign is pointed the wrong way. And again, the arrow essentially needs to point to the right if the variable's on the left. So that one's not true. So I'm going to say no, no. Well, this one looks good, okay, because y is greater than, and I don't know where they're getting these numbers from. Oh, maybe they added or something weird. I don't know what those errors are, but that's definitely not the right number. So the correct answer is just A and B. All right, number 8. The perimeter is greater than 28. What are possible values? Okay, well, the perimeter just means I add all of these values together. So I'm going to say my perimeter is 6 plus m plus 10 plus m. That's the perimeter. And I can simplify that a little bit. I can say, okay, well, 6 plus 10 is 16. M plus m is 2m. Okay, so the entire perimeter is represented by this expression, 16 plus 2m. And it says that this perimeter is greater than 28. So this needs to be greater than 28. And then I just need to solve, right? I can subtract 16 on both sides. And when I do that, you're gone. I have a 2m is greater than 12, and then from there I can divide by 2, and m is greater than 6. And there's what I'm supposed to answer. And once you use set builder notation, we can do that. We can say this is the set of m such that m is greater than 6, and the set. Okay, cool. And number 9, fill in the blanks. Okay, let's go ahead and read real quick. Bill has H hats. He buys, oh, pen's not working, there we go. Has H hats. If he buys 8 more hats, then he multiplies his total by 3, he would still have fewer hats than Jim. Jim has 45 hats. So there's 45 hats down there, I assume. Write and solve an inequality that represents the situation. Oh, there's only one option, or 3 options for blank 1. So I'm noticing that this blank is going to be multiplied by this blank. So what means multiply? And multiplies by 3, it says right here. So this one must be a 3. So over here, this has got to be a 3. So it's 3 times something. Well, what is that something? He needs to buy 8 more hats. So 8 more hats, you don't multiply by 8, you need to add 8 to get 8 more. So this is going to be h plus 8, h plus 8. And then what is this? What sort of inequality symbol do I have here? He will still have fewer hats than Jim. He will still have less than Jim's 45. He'll have less than Jim's hats. Okay, and then we need to solve this, right? So let me go ahead and do my problem off to the side. This is 3 times h plus 8 is less than 45. And then I distribute the 3 into the h and the 8. And it's going to be, oh, I forgot the 3. 3h plus 24 is less than 48. I can now subtract 24. And there was an easier way to solve this. I could have divided by 3 right away, but I'm going to do it the way that most students would solve this. And this is going to be 3h is going to be less than 24. And then from here, divide by 3, and h is going to be less than 8. So I need to say, by the way, I use this inequality here. So I want to say that h here is less than 8. So less than, let's go ahead and circle that one, less than, and I've made a mistake because 8 is not one of these options. So what have I done wrong? Let's go ahead and, oh, why did I write 45? Yeah, what am I doing? Okay, sorry. So let's change this to a 45. That's going to change that number. That's going to change that number. So this is going to be 45, Mr. Sindel. Goodness gracious. Okay, 45 minus 24 is 21, and 21 divided by 3 is 7. And this is kind of the strategy that I use on the test too. I'm like, that's not one of the answers. You don't just choose the next best thing, the closest thing to it. You go back and find your mistake. My first mistake is, did I write down the problem correctly? Often I make that mistake, and I checked that one first, and I was wrong. So the correct answer here is 7. So I put in a 7. All right, what about number 10? Select all the inequalities for which the solutions are shown on the graph. This solution is basically saying go to the right of 8, or we can say that my value of, I guess, I was going to use x, but I see all of these are using t down here. I want to make sure that t is greater than or equal to 8. Why equal to? Because there's a solid point or a closed point, and 8 is obviously the number it's going through. Okay, so I need to solve each and every one of these. Number 10 is the hardest problem on this test, and it requires the most work for the least amount of points. Let me go ahead and try to do everything nice and condensed, and I apologize at how little room there is. In fact, can I can. I have technology, so I'm going to grab all of these, and I'm going to, yep, thank you. I'm going to go ahead and copy that. And I'm going to add a new blank piece of paper, and then I'm going to write down, this is what you guys should have done. You should have gone onto a blank piece of paper and then solved each of these. So for part A, I would distribute the 4 into these, and my new inequality would be 1 plus 6t is greater than or equal to 4t minus 12 minus 3. I have some like terms here that I can combine, and I can say my next step is going to be 1 plus 6t is greater than or equal to 4t minus 15. And then from there, I'm going to move my t's around. I'm going to subtract 4t, subtract 4t. That's going to make me have a 1 plus 2t is greater than or equal to negative 15. From there, I'm going to subtract 1, moving the constants to my other side. So 2t is going to be greater than or equal to negative 16. And then I'm going to divide by 2, and now t is going to be greater than or equal to negative 8. So I want this to be, what was the answer I was trying to get? I'm trying to get t needs to be greater than or equal to 8. Well, this is t is greater than or equal to a negative 8, which is not the case. So I'm going to come back in here and be like, it was not A. Let's go to part B. For part B, let me do that under here. What would be the first step? And I'll write down the new step. So I'm going to distribute the negative 2 into these two. So it's going to be negative 2t plus 4, negative 2t plus 4. And I have plus 6t still, plus 6t. What inequality symbol am I using? I'm using less than or equal to, less than or equal to. I think I'm going to distribute a 6 next. Yeah, so 6t plus 18. 6t plus 18. I think there's a plus 2 at the very end as well. Yeah, so plus 2 at the very end. And let's go ahead and combine some like terms. So I'm combining those two, and I'm combining these two. So I have a negative 2t plus, oh, what am I doing? Those are not like terms. That's a constant, that's a variable. So let me redo that. These are my like terms because they both have variables. So let me slow down here. This is going to be 4t if I combine those two, and then I still have that plus 4. Less than or equal to, and then 6t is being added to 20. Okay, so let's go ahead and move my variables around first. I'm going to subtract 4t because I want to move my variables to a side that has, I don't know, nice positive numbers, although that's going to come back to bite me in the end, isn't it? That's going to give me 4 is less than or equal to 2t plus 20. And then I'm going to move my 20 by subtracting 20. Subtracting 20, I have a negative 16 is less than or equal to 2t. I'm going to divide by 2, and that means negative 8 is less than or equal to t. I need my t to be on the right. So the t needs to be on the right, which means the negative 8 needs to be on the left. Or sorry, t is on the left, negative 8 is on the right. If I switch the sides, this sign also switches to a greater than or equal to. I want t to be greater than or equal to negative 8. And, oh, t is greater than or equal to, I don't know why I wrote positive 8 there. It was supposed to be a negative 8 here. Obviously, this is a negative 8, and I only caught it just now. But this is, wait a sec. That is the right answer. This is the right answer, and this is the right answer. T is greater than or equal to negative 8. T is greater than or equal to negative 8. Oh, well, I guess A and B are the right answers. So A and B, how many of these are the right answers? Let's go ahead and look at part C then, shall we? All right, so for part C, I'm going to distribute the negative 5 into the t and the 4. So this is going to be negative 5t minus 20 plus 6t plus 20 is greater than negative 8. Wait a sec. I don't even need to do this. I mean, look at this inequality. These all have equal to signs, but this one does not. It cannot be C just for the mere fact that there's no equal to. Done. All right, I showed my work there, didn't I? All right, so C is obviously not the right answer. Let's look at D. All right, again, distributing the 5 into the t and the 1, so this can be 5t plus 5 minus 20 is greater than or equal to negative 25. I mean, again, I can probably stop right here because I can see the only way that there's no variables over here, there's one variable over here. It doesn't have any negative out in front, so this sign will never switch. Well, if it's never going to switch, this is going to be greater than or equal to, oh, I do want it to be greater than or equal. Maybe it is the answer. I don't know. I have to go through it then, don't I? I thought this was going to be like the wrong sign or something. Okay, so if I combine my like terms, I see 5 and negative 20. This is going to be 5t minus 15 is greater than or equal to negative 25. I'm going to then add 15 to both sides to get my constants on the right-hand side, leaving us with a 5t on the left, greater than or equal to a negative 10 on the right. And then finally, I'm going to divide by 5 on both sides. T is going to be greater than or equal to negative 2. That's obviously the wrong number. I'm looking for a negative 8. So D is clearly not the answer. Let's go ahead and cross off D. And then finally E. I know it's so long of a problem. This is insane for just 4 points. For E, Again, I need to distribute 2 times t, 2 times negative 7 is going to be 2t minus 14 is greater than or equal to, okay, I'm going to distribute the 3 into the t, it's going to be 3t, distribute the 3 into the negative 4, minus 12. Don't forget the plus 6 at the very end. Let's go ahead and combine our like terms on the right-hand side. I have a negative 12 and a positive 6, which combines to a negative 6 over here. Rewrite the rest of the problem. 2t minus 14 is greater than or equal to that 3t minus the 6. Let's move the variables. I like making positive variables, so I'm going to subtract 2t. I'm going to switch to a new color, though. Let's switch to green. Minus 2t minus 2t, and then from there I'm going to have a negative 14 is greater than or equal to just a 1t, or just t, minus 6. And then I'm going to add the 6, add the 6. I'm going to get a negative 8 on this side. Ooh, that looks promising. Is greater than or equal to a t. Again, I want t on the left-hand side, so t on the left-hand side, negative 8 on the right-hand side. When I switch sides, I need to switch a sign. This can be less than or equal to, and oh, no, I want this to be greater than or equal to, don't I? I want this to be greater than or equal to, and I have a less than or equal to, so it's not E. Whew, that was a lot of work for 4 points, but we did get the answer. It's just A and B. On to number 11. True or false? The value of 5 is a solution to x has to be greater than or equal to negative 4. However, 5 is not a solution to x is less than 1. Okay, I'm going to stop you right there. You're saying too much. Okay, I'm going to ignore you for a sec. Is 5 a solution? Is 5 greater than negative 4? Is 5 greater than negative 4? Yes, because 5 is positive and 4 is negative. So this is true. Okay. What about this one? Is 5 less than 1? Is 5 less than 1? No, that's false. 5 is not less than 1. So I agree. I agree with everything that's being said. This is true. This is true. 5 is not a solution. I just proved it right there. Okay, what is the conclusion? Therefore, 5 is not a solution to this thing. Yes, well, that's very true. I mean, this is saying 5 needs to be x, right? Is 5 greater than negative 4? Well, yes, because we saw it right there. Is 5, let me write it again. Is 5 less than 1? Well, no. So, therefore, 5 is not a solution. I agree with you. I agree with you, and it's a double negative, but I agree with you. That is a true statement. 5 is not a solution. I am agreeing with that final conclusion. There's our scratch work. We're moving on to number 12. This one was kind of tricky. So we know that the budget, we have to spend at least $399, which is kind of a weird thing to say. You have to spend money, but whatever. And it has to be less than 798. Or it's not really dollars, it's feet, but whatever. Okay, so I need to look at the perimeter, essentially, because the perimeter is the length of the fence. It's the fence there, there, and there. So I need to add up all these things together. So I'll come over here and say that the perimeter in this problem is equal to x plus the other one, x plus 90, plus the other one, x plus 30. Okay, so from here, I can add up all the x's, 3x, add up all the numbers, 90 plus 30 is 120. Okay, so the entire perimeter is 3x plus 120. And then from here, I'm going to go ahead and use my cool little shortcut and say, you need to be between the values of 399 and 798. And then from there, I can do the same thing both sides. I can subtract 120, subtract 120, subtract 120, and that's going to give us, that's gone. So 3x is in the middle now. It's still in between some values. 399 minus 120 is 279. 798 minus 120 is 878. No, 678. I can do math, I swear. All right, and then from here, I can divide by 3, divide by 3, divide by 3, and that is not a nice number, is it? So x is going to be in between things. I want to go ahead and try this one without a calculator. So the way that I'm seeing this one is this is really, really close to 200. I know 24 goes into 3, right? Because that's 8. So 240 goes into 3. So 240 plus what is 279? 240 plus, that's going to be 39. Okay, so this fraction and this fraction are the same. That's easier to do because that's just 8 with a 0. 39 divided by 3, well, 3 divided by 3 is 1. 9 divided by 3 is 3, so it's 1, 3. So 80 plus 13 is 93. Okay, what about for this side? 678. What's a number that's like 600 and something that's divisible by 3? Well, I know 690 is divisible by 3. Do you know how I know that? 690 is divisible by 3 because 6 is divisible by 3, 9 is divisible by 3, and also you can just add all the digits, right? 6 plus 9 plus 0 is 15, and then for 15, that's 1 plus 5. 1 plus 5 is 6. 6 is divisible by 3, therefore 690 is divisible by 3. So I know that's divisible by 3. In fact, that is going to be equal to, well, let's just check. 6 divided by 3 is 2. 9 divided by 3 is 3. I don't know why I'm writing it like that. And 0 divided by 3 is 0. So that's 230. Okay, and I went overboard a little bit, so I need to subtract something. So how do I get from 690 to 678? And you might have been saying, oh yeah, you just subtract 12. So that means I'm subtracting 4. 230 minus 4 is 226. 226. Okay, so what have we figured out? We figured out that because of these bounds on our constraints, we need our answer to be between here. So can't be 90 because it needs to be bigger than 93. It can't be 227 because it needs to be less than 226. It can't, oh, I guess it can be. No, it cannot be 250. 250 is still too big, bigger than 226. 175 is in the sweet zone in between these two values. The correct answer here is D. Number 13. Ooh, okay, this one's going to be kind of interesting. Do I have enough room to do this on the side? I'm going to go ahead and write it up here. So I'm going to distribute the negative 6 into the n. That's going to give me a negative 6n. Distribute the negative 6 to the negative 1. That's a positive 6, and that has to be less than 3. I'm going to go ahead and solve that really quick. I'm going to subtract 6, and that's going to be negative 6n is less than negative 3. From there, I'm going to divide both sides by negative 6, divide by negative 6. Remember, we're dividing by a negative. This sign is going to flip. This is going to be greater than now, and I have n, and negative divided by a negative for the right-hand side is a positive. 3 divided by 6 reduces to 1/2 or 0.5. I chose 0.5 because I looked ahead and saw, oh, they're using decimals and not fractions. Okay, so that's the first inequality. What about the second inequality? This one right here. So we need to distribute yet again. 2 times n is a 2n, and 2 times 1 is a 2, and that's to be greater than 0. Let's go ahead and solve, and I subtract 2, so 2n is greater than a negative 2. Then we divide by 2, and n has to be greater than negative 1. So both of these are going in the same direction, which is interesting because essentially what this is saying is this exactly, like this is the graph of that. This second one is the graph for our second inequality, and we need to combine it using the word or. This is not exclusive or, this is inclusive or, which means it can satisfy this one and it can also satisfy this one. Either one is okay. So let me ask you the question. Is this 0 is a perfect test point because I love plugging in 0, right? Is 0 greater than negative 1? Yes. Therefore, 0 should be in the final answers. So the question is really, which of these two answers is it? Well, 0 is not in the solution for this one, but it is in A. So the correct answer here is A. All right, runabout number 14. Just solve it and using set builder notation. Okay, I don't have enough room to do it, so I'm going to go off to the side here. I'm going to just say negative 3 plus m is greater than or equal to 9. And then I also have 1 plus 2m is less than or equal to 19. I have to solve each of these. So I just need to add 3, and m has to be greater than or equal to 12. Okay, what about this one? I can subtract 1, so I get 2m is less than or equal to 18. Then I'm going to divide by 2, m is going to be less than or equal to 9. Okay, and I need to combine this using the word or. So let me make a quick little sketch of a graph for each of these. This one is saying, hey, you have a point here at 12. It's a closed point, and it's greater than or equal to, or you can view this as it's an arrow going to the right. And then for this one over here, I have a closed point at 9, and it's saying less than or equal to negative 9, so it's going that way. And it's combining it using the word or, so either one will work. And I noticed that if I graph them on the same number line, the same number 9 line, 9 is over here, 12 is over here. They're both closed points. 9 was going to the left, and 12 was going to the right. So we basically just need to say that as our answer. So our set notation officially would look like this. We'd say our solution set, I need to write really small to fit in here, don't I? The solution set is a set of all m such that m is less than or equal to 9, or m is greater than or equal to 12, and the set notation. Whew, that was a bit. All right. Number 15, solve. Okay, so normally you have to isolate the absolute value, which it already has. There's no like +1 or ×2 or anything like that. We've isolated the absolute value, and then it's time to turn it into two separate equations. So our first equation, we just drop the absolute value symbol. You say h minus 4 is less than 14. The second one, we drop the absolute value symbol. It's still h minus 4, and then everything on the outside got multiplied by -1, which is not really what happens, but that's our shortcut. So this thing is going to be turning into a greater than, and then this 14 turns into a -14, and we solve each of these. Add 4, add 4, add 4, add 4, and our final equation, therefore, is going to become h is less than 10, h is greater than negative 10. So we want to be greater than negative 10 and less than 10. So I have to be careful here. I don't write 10 here and negative 10 because that would be wrong. You put the smaller one on the left and the more positive one on the right. So the more positive one is 10. The more negative one is negative 10. And now I have my final answer. I need to be between those two values. Excellent. All right, number 16. We're getting close to being done. We got a word problem. Let's go ahead and read. Mrs. McGee, or Miss McGee, sorry, spends 43% of her working day doing research. The margin of error is 2%. Pretty small and good. Miss McGee says that this absolute value inequality and its solution set are representative of the range of time t that she spends doing research. I spend minus 2 less than, okay, I don't know, some equation. I'll read it. Okay, and the solution set is that. That just feels wrong. So I know from our last problem that our outside changes to a positive and a negative version when we drop the absolute value symbol. There should be a negative 43, and then it's barely changed by that too. One of these should be negative. That is false. Okay, I'm going to go ahead and assume that that one is true. I don't even know if that is true, but let's go ahead and just assume it is. Watch what happens. From here, there should be two different inequalities that pop out of this. One of them being t minus 2 is less than 43, and the other one being t minus 2 has to be greater than negative 43. On both of these, you add 2, add 2, add 2, add 2. This one becomes t is less than 45, which, I mean, it kind of, I see a 45 here. And this one is saying t is greater than a negative 42. And there's no negative 42 anywhere in this problem. Therefore, this has to be a false statement. All right, number 17, describe the graph of the solution set of that thing. Well, I need to solve it and then I'll do it, right? So let's go ahead and turn this into two separate equations. So the first time I'm going to drop the absolute value symbol. So it's going to be 2x minus 2 is going to be less than or equal to 24. And then the second inequality is going to be 2x minus 2 again. Same inside, but now the outside is going to flip. So it's going to be greater than or equal to and a negative 24. Okay, let's go ahead and solve these. I have a plus 2, a plus 2. It's going to be 2x is going to be less than or equal to 26. Over here, plus 2, and this is going to be 2x is going to be greater than or equal to negative 22. Then from here, I'm going to divide everything by 2, divide everything by 2, divide everything by 2, divide everything by 2, and that leaves us with x is less than or equal to 13, and x is greater than or equal to negative 11. So what does that look like, though? On a number line, I have negative over here, negative 11 on the right, and positive 13 on the left. They're both closed points because they both have an equal to symbol. This is saying go to the left of 13 because it's less than 13, so that means I'm going this direction. And this one is saying go to the right of 11, go greater than negative 11, so it's going to go this way. And if I go ahead and extend that logic all the way through, this is just a line that connects the two, and I have my graph. So if you gave that graph, I would probably give you full points. But if you want to go ahead, it says describe. Usually that means using words. So I'm going to go here and just type out. I'm going to say, there we go. See, I need to see, it's negative 11, 13. Done and done. Closed points at negative 11, 13 with a line in between them. Perfect. All right. Number 18. Ooh, match the graph to its inequality. Okay, so, wait, there's 3 inequalities here, but 2 graphs. Third graph is over there. Huh. Oh, interesting. Okay, so this graph has a solid line, and these 2 graphs had dashed lines. Okay, well, which one is a solid line? That has a solid line because of the equal to. So let's go ahead and back here. Okay, so C goes here. That one's pretty straightforward. Okay, how do we decide between these two? And I don't know how to do this. Let's just do a test point, yeah? My favorite test point is available because not online. This test point, if it is in the solution set, then that's the right one. So let me just go ahead and test this one. I'm going to say, okay, 0, it's going to be 2 times 0 minus 5 times 0 is less than 10, which is the same thing as 0 minus 0 is less than 10, which is, why did I write there? Here we go. 0 is less than 10. Well, this happens to be a true statement. 0 is less than 10. So that is a true statement. True statement means it is in the shaded region. This is in the shaded region. Therefore, B is the right answer here. And by process of elimination, the next one has to be A. CBA. It's just backwards ABC. All right. Number 19. True or false? The graph shows this thing. I don't know. I have to solve that then. I'm going to go ahead and get rid of the 5 by adding 5, and this is going to give me negative 8y is less than or equal to 0. And then finally, I'm going to divide by a -8, divide by -8, and y is, well, 0 divided by -8 is just 0. And be careful here. We divided by a negative, which means this sign is now going to switch to a greater than or equal to. My hint to everyone is if you get y on the left-hand side and you have a greater than, that means it should be shaded above, and this one is shaded below. So just from that shortcut, I know that's not the right answer, but let's go ahead and do a test point. I'm going to test this point right here, which is the point 0, 2, aka the x coordinate is 0 and the y coordinate is 2. There's no place to plug in an x anywhere over here, so you don't have to worry about it. Kind of nice. But the y coordinate is 2, which means I need to plug that in. I have to say that 2 has to be greater than or equal to 0. That's my test point here. And that happens to be a true statement. If this is a true statement, it should be in the shaded region, but it's not. So this is not okay. This is false. All right. In our last problem, number 20, which is a bad problem because this doesn't work. I can even show you and prove to you that it doesn't work. But you can do the first 3 questions. So I only go to the first 3 on our actual test for this year of 2025. The solution set of that graph is on a coordinate plane. Does the test point work? So immediately just shove it into the test point, right? You can say, okay, well, that x is now 0. So I'm going to go ahead and say that's now a 0. That y is now a 0. What happens? 5 times 0 is 0. Minus 2 times 0 is 0. And that should be greater than 9. So is 0 minus 0, which is just 0, is 0 greater than 9? No, it's not. This is false, right? So you want to say it is not a solution. So we can come down here and say is not a solution to the half plane. If it's not a solution, then it does not contain that point. So it does not contain the point. Okay, what sort of boundary line will we have here? Well, because we have no equal to sign, we will have a dashed line. This will be a dashed line. I can go ahead and circle that. And the next questions don't work. These should really be odd numbers, and they're not. And I'll show you why this doesn't work. I think the fastest way to do it is just to use technology and prove to you. If I get my graphing calculator out, watch what happens when I enter this equation, 5x minus 2y is, I'm just going to say equal to for now so you can see the line, and then you don't have to worry about the shading, is equal to 9. There's the graph, right? So we should be able to see lattice points, or points that are on the crosshairs at -2, 0, or 4. So if I come over here, let's make this a little bit bigger so I can see what's going on here. At -2, let's go here to -2, Mr. Sindel, -2, comma, it looks like it's approaching -9.5, I think, -9.5. So there's the first answer. If you plug in -2, the output should be -9.5. Notice, -9.5 is not one of these options. All of these options are whole numbers, and all of these options are also whole even numbers. Even numbers won't work. So -2 cannot be there because otherwise this option should have been a -9.5. Well, Mr. Sindel, what about a 0? Does that work? Well, let's test it, shall we? If I plug in the point 0, 0 should go to -4.5, comma. I'm just eyeballing on the graph. I think it's about -4.5, -4.5, and that point is indeed on the graph. And notice how -4.5 is not one of these options. And then finally, well, maybe the process of elimination. It must be 4 then, Mr. Sindel. Well, watch this. If I go to 4, then I get the output. It looks to be about 5.5, 5.5, yeah, 5.5. 5.5 is not one of the options, which means that's a bad problem. You can just right here, this is a bad problem. For future years, this is how I plan on modifying it. For future years, I need to see that screen so I can get a good answer. For future years, I think what I'll do is I'll change all of these to odd numbers. So let me go ahead and type this into slope-intercept form. So this is going to be y equals, I'm going to divide -5 by -2, so it's going to be 5 over 2, or 2.5x, and then 9 divided by -2 is -4.5, so -4.5. And you'll notice that's the exact same line. I'll even turn off the old line. And I can change this into function notation. You can see some cool tricks that Mr. Sindel uses. This is f of x, so the function notation, and I can test some things out, right? What is f of, and I can test out, let me just plug in 1. F of 1 is -2, so I'm going to go ahead and plug in 1 right here. And I'll choose 0, and I'll choose maybe some other even number. Now, let's do 4 again, because I know that 0 and 4 did not come out nice. And then I'm going to come over here, and I'm going to give some whole numbers. Let me just change one of these to a -2. I know that these can't be options. That's how teachers' minds work. They say, okay, just make one of them good. That one and that one are good, so that's probably what I'll do. So the answer should have been something like this, like through, wait a sec. Is this a good problem? It tells you, these are the y coordinates, Mr. Sindel, or this is the y coordinate. Oh my God, this is not a bad, I'm being so silly. I'm like, these are x and y coordinates. Oh my God. Well, okay, I apologize for recording this video. I misthought about this. It has to go through 1. If it goes through 1, you can just plug in 1 into y, and you can solve it. Here, let me do this without a calculator and actually solve it the correct way. I'm so embarrassed. All right, this is gonna be 1 comma what? Well, 1 is x, so it's going to be 5 times 1 minus 2y. I'm just going to say it's equal to 9 for now. Therefore, this is going to be 5 minus 2y is equal to 9. I'm going to subtract 5 on both sides. Subtract 5, and this is going to be -2y is equal to 4, and therefore y is equal to a -2. And oh my goodness, I didn't have to change the problem. I just had to read better. That's frequently my problem. -2 has to be the answer. And if the y coordinate is 3, that means this 3 is being plugged in for y. I can come over here and say that this is 5x minus 2. Okay, our y coordinate is 3. It has to be equal to 9 for a sec. This is going to be 5x minus 6 is equal to 9. Let's go ahead and add 6, and 5x is going to be equal to a 15. It came out nice. Oh my goodness. Oh, divide by 5. I jumped to the answer in my head and I wrote it down. Divide by 5 and x is equal to 3. The correct answer was 3, -2 and 3. Okay, that could have been out of 5 points instead of out of 3 points. It was a good problem. Good job, math. Well, that does conclude, it ended on a bad note of me making a mistake, but mistakes are good things. It ended on a good note. Let me take that back, right? All right. That does conclude the Module 6 assessment for Integrated Math 1. Thanks for watching. I'll see you guys later.